In this video, we are going to do an expected value example that involves a tree diagram. So the question says that a bag contains 6 balls labeled 5, 5, 5, 6, 6, and 8 respectively. We draw 2 balls without replacement. Let x be the sum of the numbers and let y be the minimum of the numbers. So that means y is going to be the smaller of the 2 numbers that are picked. And then find, part A asks the expected value of x. Part B then asks the expected value of x times y. So there's more than one way to do this question, but the fact that there are 2 stages, picking a first ball and picking a second ball, and the fact that we're doing this without replacement, suggest that a tree diagram may help. So that's definitely going to be one way to go here. So I'm going to work this out using a tree diagram. All right, so I'm going to zoom it out a little bit just so I can draw and look at this problem still. So I'm going to write a section for where we begin the tree diagram as well as the stages. So I got to keep track of the first ball that's drawn, the second ball that's drawn. From there I can write down the outcome and the probability. So I'll start with that, but once we get to that point, afterwards I'll start to keep track of my random variables and their values. Okay, so for that first ball, it could either be a 5. Let's put this in black actually. So that first ball could be a 5. It could be a 6. Or it could be an 8. Okay, and if the first ball is a 5, well then one of the 5s is gone, but you still have 2 5s, 2 6s, and an 8 left. So if you did pick a 5 first, there would still be 2 5s, there would be 2 6s, and there would be 1 8 left if you got to this point. Okay, so we could pick a 5, we could pick a 6, and we could also pick an 8. If we had picked the 6 first, well, in that situation, we would have 3 5s. We'd have 1 6 and 1 8 left. So we could pick any of the numbers. We could pick a 5, we could pick a 6, or we could pick an 8. Finally, if we had picked an 8 first, then we would have 3 of the 5s and 2 of the 6s left. So we could only pick from here either a 5 or a 6. Okay, so the outcomes are 5 and a 5. I'll just put a comma between them. 5 and then a 6, 5 and then an 8, 6 and then a 5, a 6 then a 6, a 6 then an 8, 8 then a 5, and then finally 8 then a 6. Now let's label some probabilities here. So the probability of picking a 5 initially for the first ball, well, there's 3 5s out of 6 total balls. So that gives us 3 over 6. And we could simplify that. That becomes 1/2. The probability of picking a 6 would be, well, there's 2 6s. So we'd get 2 over 6, which simplifies to 1/3. And then the probability of picking an 8 is 1 over 6. All right, so now suppose we picked a 5 for the first ball. I'm going to do these 3 branches slowly, and I'm going to do the remaining starting from the 6 and starting from this 8 down here more quickly once we get the idea. Okay, so from this 5, if we had picked the 5, we've already written down there'd be 2 5s left, 2 6s left, and 1 8 left. So 5 total balls left. So the probability then that I pick a 5 next would be 2 over 5, because there's 2 5s left out of 5 total. Same thing for a 6, it would be 2 over 5. For the 8, it would be 1 over 5. Okay, so starting from the 6 now, going to the 5, 6, and the 8, I see there's 3 5s out of 5 total balls left. So this is going to be 3/5 and these other two probabilities are going to be 1/5. So 1/5 there and 1/5 here. And then these last two branches, 3/5 probability here and a 2/5 probability there. So for these final probabilities, I'm gonna multiply these. Let's zoom it in a little bit now. So when I multiply these, I'm just gonna go ahead and write down what we end up getting. So I've gone ahead and done any sort of cancellation ahead of time. I'm just gonna tell you what we get. So this one ends up being 1/5. Then I get another, oops, I need to make this a little bit smaller. This is 1/5. And then it is 1/5. And then it is 1/10. Whoops, 1/10. And then I get another 1/5. And then 1/15. And then one more 1/15. A 1/10. And then finally another 1/15. So those are my probabilities. So now, because we have these random variables, I'm going to make some extra columns. Okay, so I'm going to make a column for the random variable x, for y, and then we also care about x times y, so I'll make a column for x times y. So what is x? X is the sum of the numbers. So in the first outcome, 5 and 5, the sum would be 10. And then with 5 and 6, the sum is 11. And if I keep going like that, let's see, 5 and 8 give me 13. Then this is 11, 12, 14, 13, and 14 for those sums. Y is the minimum of the two numbers. So if my two numbers are 5 and 5, the smallest number is a 5. If the two numbers are 5 and 6, let's write that better, 5. If the two numbers are 5 and 6, the smallest, the minimum is a 5. Same thing if it's 5 and 8, the minimum is a 5. If the numbers are 6 and 5, the minimum is a 5. So let's write the remaining more quickly. This will be 6, 6, 5, and 6. So now to form the values of x times y, we multiply the values of x with the corresponding values of y. So 10 times 5 is 50, 11 times 5 is 55, 13 times 5 is 65. Let's do these more quickly now. This is 55, 72, then we'll get 84, 65, and then again 84. All right, so we have this tree diagram. So now we're ready to write down these expected values. It's going to be really similar for these two now that I have the column for x and the column for xy. So I will just solve b, because A is going to be super similar now that I have this tree diagram. So the expected value of xy, to form this, I just take each of these values, like 50, that's the first one I have listed, multiply that by its probability, which is 1/5, and I keep going like that. So next I have 55 times its probability, which again is 1/5, and then plus 65 times its probability, which is 1/10. If I continue in this way, we get plus 55 times a fifth plus 72 times 1/15. We get plus 84 times 1/15 plus 65 times 1/10 plus 84 times 1/15. So we got to evaluate this. This I can actually do without a calculator. It helps if I group terms that have the same denominator together. So let's do denominator 5. Let's highlight them in yellow. So there are two terms that have a denominator 5. Actually, well, there's a third one. So there is a third one over here. So if we add their numerators together, we'll get 50 plus 55 plus 55 all over 5. So now let's do the terms with a denominator of 10. So here's one, here's a second one. So just those two. If we put those together, we'll get plus 65 plus 65 over 10. Let's highlight that one in blue as well. And then we have a denominator of 15. Let's put those together. So 3 of these. So adding those, we get 72 plus 84 plus 84 over 15. And let's highlight that in green. And if we work each of these out, they each become a whole number, which is nice. So this is 32, then I get plus, the next one is 13. The last one ends up being 16. And if I add these together, we get 61. And that is our answer. I'm going to end by saying two quick things. So the first is a cautionary warning. So be careful. And be careful about the fact that the expected value of x times y is not equal to the expected value of x times the expected value of y in general. When we're adding x and y, this is true. That was a theorem that we saw. So recall, it was this theorem in one of our previous videos. The expected value of x plus y is equal to the expected value of x plus the expected value of y. But I can't say something similar about multiplying two random variables in general. There is a special case when this is true, and when they are equal, and that's when x and y are independent. I'm not really going to cover that in this class. That's something that I would talk more about if this was a more in-depth statistics course. And the final thing that I'll mention is we never actually did part A, but I'll just say that A is very similar. Now that we did part B, our technique for computing A would be virtually identical to what we did here. All right, so coming back to our goals for this section, we finished our last goal, which is to compute the expected value over the course of several examples.